Yes, sir. Paresh, sir.
Yes, sir. Yes. You
Okay,
can
okay.
continue, sir. Welcome
Okay.
again.
Yeah, thank you, sir. So we have seen one exercise of generating 1 kilohertz pulse at PD 12 pin, and also on the PD 13 pin we have seen the one LED blinking at the rate of 1 second. So now we will move on to the second exercise. So which is second exercise, we are going to uh, use this keyboard buttons, the digital input command to our controller, and we'll see the operation. Okay. So on the push button command, we will operate our LEDs. So that way we have programmed this. So I am sharing my screen. So is it visible, my screen? Okay, thank you. So what are the familiar blocks from the last exercise?
G4D.
Yes, digital output block is familiar. Okay, and this target setup block is familiar. But this PD6, sorry, this digital input and this debounce is new, and this not logical operator, which I will explain why we have used. Okay. So first let us see this PD12 and PD13 pin, same pin, the same configuration we are using, and as we have seen in the as we have seen in the our this control motherboard, there's this PD 1 2 3 10 11 is our LEDs, and this PD 3 4 5 6 7, these are push button, which we can use incorporate as a input command. Okay, so this PD 13 14 and sorry, PD 3 4 6 7 will give command to the our controller. Okay, so that's why we have selected this digital input. The digital input block we can get from here. This Wajung block set STM32 F4 target, then on chip peripherals, then IO, then we will get this digital input block. Okay, from there the same setting as the digital output. The port you have to select according to the your controller on your hardware requirement, and we have selected port D, and we have selected pin 6 and 7. Okay, so the PD6 and PD7 buttons will work as a push button, and okay, then we move on to this debounce. So debounce is what? So in this debounce block, there is a this mode, this toggle latch, the normal mode, single pulse, and toggle latch mode. Okay, so I'll quickly show you what is this three mode: normal, single pulse, and toggle latch. So this is normal mode. Okay, I'm just first writing. Don't mind my handwriting. I'm writing through the mouse. Normal mode, toggle latch. And then there is pulse. Okay, so in the normal mode what happens is, whenever you press the button, so let's say you have pressed the button here, and as long as you keep pressing the button, so initially you're in this zero state. Okay, let me write it here. This is 0 0 0. Okay, so in the normal mode, where as long as you press this, initially you are at this zero state. So when you press this button, so let's say you have pressed the button here, so that it will become 1, and it will remain 1 as long as you press the button. As and you, whenever you leave the button, so that it will again come to the zero state. Okay, so this is how, and when you again press this button, it will come to the one state, and it will remain at the one state until you have removed it. Yeah, okay. So, and the toggle latch mode, what happens is, let's say this is one state now, and then this is zero state. So when you press this toggle latch push button, and it is on the zero state, and it will change the state to 1, and it will remain to 1 until the next command is given. And when you give the next command, it will again come to the zero state, and when you press again, it will come to the one state, and it will remain in the one state. And when you press it again, it will come to the zero state, and it will remain in the zero state. And in the pulse mode, if when you press the command push button, let's say you have pressed it the initially, so it will give you the pulse only for one time, and it will be 0 after that. And if you press again the button, it will give you the pulse again, and it will be 0 again. Okay, so this is how this mode of the normal, toggle latch, and pulse mode occurs. Okay, so I think this is clear.
Sir, in the pulse mode, if we press it, then also it will get 0 or what?
In the pulse mode, what?
How it will work? The pulse
In the
mode.
pulse mode, when you press the button, it will be only on for one cycle, and then it will be 0. Even if you are holding the button, it won't be coming to one state. Okay, it will remain
For
1.
the instant, it will be 1. Then
Yes, yes,
again,
yes.
okay.
Yeah, exactly. Okay, so I think this is clear.
Yes, sir.
Okay, so we will move on to the further. And why we are using that note is because we are initially our controller is designed as it will be remaining as a high. Okay, so for that, let's say this is 1, and this state is sorry, this state is 0, and this is staying 1. So our controller is designed as it will be staying 1. So in order to get this 1 to 0, we are using the not gate on here. Okay. Okay, so that we will see on the operation, and with this PD12 pins, and we will see that toggle latch command and the normal mode on the PD13 pin.
Can you
Okay.
please explain once again the logical operation?
Okay, logical operator. Logical operator is what here is a not command. So what it will do? If 1 is here, it will give us 0, and it will give us 0 here, and it will give us 1. So that's what we have done. So initially our controller is designed that it will be giving us a 1. So in order to do that 1, to bring it back to the 0 state, we are giving it the not here. Is it clear?
Okay, okay.
So we will see the experiment of this. Okay, I'll again stop and again share. Okay, let me motion. Okay, I think it was, let me check if it is.
So this exercise is for digital input operation. Generally,
Is it audible?
Yes, sir, it is audible, sir.
Yes, it is audible.
Okay, okay.
We are using key for doing a digital input operation. So we have already discussed that we have connected key as PD6 and PD7. This two pin is connected with two push button keys, and its output we will detect inside the controller, and that output detected inside the controller we will give back to the LED connected at PD12 and PD13. So when we press PD7, at that time its output will come at PD13, and when we press PD6, at that time output will come at PD12. But the difference between these two operations is that at PD6 some debouncing block is connected. So this block is with we are using with a toggle latch operation. So toggle latch operation means when we are pressing PD6, at that time it will latch the output here. So when we press one time, it will make it on or 1. When we press second time, it will make it 0. So it is independent of releasing operation. So if we release, then also that output will be latched here, that we will see in experimentation in downloaded program in the controller. So in PD7 what will happen without this block is that, so till you are pressing the key, here one output will be there or LED will glow. So when you release the key, at that time it will become 0. So this is the difference between these two operations that we will see in the experimentation. Now we will go for experiment. So here in the experimentation, this is the same kit we have already explained the different pin configuration and about the controller. So now as we know already that here we have connected some LEDs with the D port of this controller, and there are keys which is connected with E port. So E port as well as D port. So here LEDs are here and keys are here. So as we have programmed the two key, that is PD7 is here, PD6 is here, and corresponding output we are observing at PD12 and PD13. So this LED is PD12, this LED is PD13. So output of PD7 pin, when we press it, so let me press it, and we will see that this LED, that is PD13, it will change its status. So see, I have pressed continuously I am pressing it, its status become 1. When I release it, it becomes 0. So let's repeat it again. So when I press this, here this is the PD13. Actually here some printing mistake is there. It is written PD10, but it is not PD10, it is PD13. This is 12, 14 and 15. This is PD15. So when I press here, till that only this key this LED is glowing. When I release, it becomes 0. So this was the operation of PD7 as the input and PD13 as the output. Now PD6. So now PD6 is here. When I press it, its output will come here. So if I press it, it is on, similar to PD7 operation. But when I release it, still it is glowing. So releasing operation is not affecting the status of the key. Now let me press it again. When I press it again, it becomes 0. If I release, then also its status is remained same. So we can differentiate between these two operations like that. Let me demonstrate it again. So when I press PD6, at that time it is turn on. When I press second time, it becomes turn off. So it is according to the pressing. If press one time, it is on, second time it is 0. One time on, second time 0. But it is not a case with PD7. So in the PD7, if I press, it is on. When I release, it becomes 0. If I press, it is on. If I release, it is 0. But in the PD6, if I press 1, it on. When I press second time, it 0. Again press 1, it is 1. When press, it is 0. So we can use this latch the mode of the key operation for turn on and turn off of our drive, that we will see in the other exercises.
So I think it was pretty much clear. So can we move further to our next exercise?
Yes, sir.
Okay, thank you. So in this exercise, we are going to see the interfacing with the LCD. So 16 cross 2 LCD, which is available on this our STM controller. I think my screen is visible, right? Yes, it is sharing. Okay. So what are the new blocks you are seeing in here?
LCD character setup.
LCD character setup, right? Then
And this triggered subsystem.
character LCD, right? Okay. Then volatile data storage was again, and this triggered subsystem is also available here. Okay.
Yes, sir.
So these all blocks are the same which we have seen in the previous program. Okay. So this is some new blocks we are going to see. So the character LCD is so much important right now. So that let's say you are let's say the examples. Take the example of yesterday's session itself. That we have seen the simulation of buck converter. Okay. So in the buck converter, if you want to do the closed loop control and you want to change get the voltage of output voltage, so you have connected some sensor at the output voltage and you are sensing it through the ADC channel and you are giving it to the controller. So you will it is required that you display that quantity what is the reference voltage you are giving and what is the actual voltage you are sensing right now. Okay, so that you have to display it on in order to make it aesthetically clear. Okay, so it is properly you can observe that your boost converter is working properly in the closed loop control. Okay, so that's why we have to use this interface with the LCD. So with that, as we have seen, this target setup block is required to get this control, this program that which controller we are using. So for the configuring the LCD, this character LCD setup is required. So there's some minor change where you get this this character LCD setup, which is this not from this STM32F4. Rather it is from this hardware modules. Hardware module, you have to go to this character LCD, then character LCD to this simple AMG CLCD display setup. Then you can get this LCD setup block. This character, sorry, LCD display. Okay, okay, here character LCD setup. Sorry. This is character LCD setup block. From there you can get this character LCD setup. And this LCD setup block, you have to get this volatile data storage and also this character LCD write. Okay, character LCD write you get from character LCD. Okay, these two blocks you get from character LCD, character LCD setup and character LCD write, and this volatile data storage you get from this LCD setup. Hope this is clear. And then the changes are to be made in here. Let me first compile it. So as you may have seen in here that this LCD section is here. So on the LCD section, we have provided some dedicated pins for that to get this read write and reset and enable pin and register select. Okay, so that we have provided some pins, configured this pin here. Okay, So accordingly, we have to select the pins in this block. Okay. So module, we have to select this as a 1. Interface, you can select either 4 bits or 8 bits on your any of it. And number of columns, as we are using this 16 cross 2 LCD. So that's why we have selected the number of column as 16. Okay. Then GPIO output type should be push pull. Okay. Then GPIO should control port we have to select is port B. After selecting the port B, the register select pin you have to select as 11. Register read write is to be 10, and enable pin is pin number 2. Okay, and the data port pin are this E port. Select the port E, the data pin D4, 5, 6, and 7. Okay, so if you want to take a note, I will be keep it for a few seconds, and you write it down or take a screenshot, whatever you want. Okay, so we will move.
Connecting this particular STM32 with the normal 16 cross 2 LCD, which can be also used to connect with the Arduino board. That can be directly connect. That can be we can connect the 16 cross 2 LCD with this block.
Yeah. You can connect it in the directly on this board here.
Okay.
Okay. Here the pin. Here are the pins. So you can remove this LCD and you can connect your that LCD. Okay. Okay. So is it this was clear, right?
Yes, sir.
This character LCD is
For that,
clear.
sir, for that also we need to select the
Same
block
configuration. This
in the same
same
way.
configuration. Yeah. Because this pin are terminated at the this controller board, not on the Arduino's LCD. Okay.
For any kind of LCD, these parameters are fixed.
Yeah. Okay. So moving on further. This volatile data storage we are using. So in this exercise, sorry, I didn't mention what we are doing here right now. So we are doing this, that we will be pushing, we are using this push button command, and we will be toggle, we will see the LCD will be displayed that whenever the switch is on, it will display on, and it will when we press the button again, it will display us off. Okay, that's the simple program we are uh, trying to program here. So in order to do that, so first we have selected this LCD setup. Then this is volatile data storage. So volatile data storage, you have okay. So I So volatile data storage. So in which your data coming from your command is coming. So you have to give some the storage some name. So we are giving it the name on off. We have set the size of it as 16 bytes. Then initial value at the whenever the controller is reset, what will be it will be showing us the value. So we have set it to the offset. And sample time, as always, we have kept -1. Inherently it will take. And storage type, we are using a string. As you know that this is alphanumerical value will be coming here. So right now it is alphabetical value, so it will be, we have selected as a string. Okay. And in this character LCD, right, whatever the data coming in this volatile data storage, it will be getting from this here. The data coming in here will be displayed by this LCD, right? Okay, so it will take the data from this volatile data storage. So for that we have to select this buffer. So we have created this buffer of string type buffer with the name of on off. So we have selected this, on off buffer. So whatever the data coming in here will be displayed by this character LCD write. Okay, so this command, this three three things are there you have to give. So this X position, then the Y position, then this is command. So command, with that I will come back to it later. And this X position and Y position. So X position, Y position means, let me draw it real quick. This is your X position, and you know that you are having 16 cross 2. Okay, I'm not properly and with accurately. So let's say this is your 0 position, 1 2 3 4 5 6 7 and up to, it will be up to 15. And 16 cross 2 means you have two lines. So this is 0 line, Y position 0, and this is Y position 1. Okay, the same way. So it will be displayed like this. Whatever position you want to select, you want to display on the second row, third column, you have to, third column and second line. So you have to give the X command 2 and Y command as a 1. Right now we are selecting it as 0 and 0. So it will be displayed here on, and off will be as here, off. It might be some change in the video that it is here on, off. Okay, so I think this is clear, right?
Yes, sir.
Okay, so that, and the command part. So command part is that let's as I said earlier, that you are taking the voltage and you want to display the voltage on the your LCD display. So at the it will be taking the voltage at the rate of your sample time, right? So it is up to this 0, this command, that if you give it a 0 command, the whatever the new value coming in this volatile data storage, it will display this, it will erase the full LCD and display, or it will not erase the full LCD and it will overwrite it. Okay, am I clear to everyone?
No, sir, not getting, sir.
No, sir.
Okay, yeah. That yeah, I was just making sure that I'm not getting it. Okay, so let's say you're at the sample time, at X sample time, and you are getting the voltage of let's say 15 volts, right? And at the sample time X plus 1, you are getting the voltage of 15.1, let's say. Okay, so to display 15.1, whenever you select this command as 0, so this will erase the old 15.0 and it will again write the 15.1. And if you set this command as 1, it will not clear the 15.0, it will just 15.1. Okay, it will not clear the earlier value. Okay, it will just overwrite it if you keep it 1.
Yes,
So I think this is clear. And coming back to this part, so this is triggered subsystem. So this trigger subsystem you can get from this Simulink library. It is easily you can get. So then in this there is some new block. It is a buffer. It is not buffer. It is a printf block. Printf block, you can give whatever you want to print here. If you are getting, let us say I said the that I said voltage you are getting. So voltage you can if you give it here, the put is equal to before this on command percentage 2.2. So you get this arrow. So whatever the value you give in this, it will be coming on the this printf block, and where it will be storing that data. So the whatever you have selected the buffer, there it will be store your data. So right now we are selecting the on off. Okay, so right on off, and we will select this just display. We want to just display the on. Right now we are not having any varying quantity, so this we are not needed. So okay, the on. So trigger system. What is this trigger block? This rising edge. Trigger type is rising edge. Okay, so as I explained that the toggle latch and everything. So let's say you are this is your push button command. Okay, so initially it is 0, and this is your 1, and here you push and turn off. So this trigger subsystem, what it will take is, we have selected the detect the rising edge. So whenever it will detect this rising edge, it will enable the subsystem. So when it will enable the subsystem, the content in this subsystem will be enabled, and this on will be stored to this storage data storage, and this volatile data storage will give the command that here it is on, so that this LCD write will display as on. Okay, and once again when I press this push button, and it will come from 1 to 0, and it will be falling edge, so that this other block will be detect falling edge. So in this other block right now, right here, so you can see that it is selected as a trigger type of falling, so it will detect the falling edge, and it will activate this subsystem. So in this subsystem, it is we have kept as off, so it will display, it will give the that command here is coming is off, and it will give it to the volatile data storage, and volatile data storage will give that here I have the command, I have the value data of the off, and this LCD write will display that it is off. Okay. Is it clear?
Sir, but I want to know what is the function of this volatile data storage. Just for
Yeah.
temporary storage it is.
I don't get the what is the what do you mean by temporary?
Means for just for some time can we store the data in it or what?
No, it will be continuously storing the data.
Okay.
Okay. So let's as I said that voltage it will be in the closed loop operation, it will be varying. So in that time your voltage coming from the ADC will be continuously changing, so it will be updating at the time at the sample rate. Okay, that whatever the sample time you have given.
You mean to say we can see all the previous value which is stored in the volatile data storage?
I didn't get what you are suggesting. Can we repeat it?
Sir, you mean to say that we can get all the data which is stored in the volatile data storage anytime?
Yeah, but it should be in the limit of your LCD display. So let's say if you want to type the name of your the full name of, let's say, SSBT college full name, and if it exceeds the 16 column, then it will only display the up till the 0 to 15 in whatever the coming in the 16 columns. Other than that, it won't display.
Right.
Okay, shall we see the experiment video?
So for the build to build in the STM32, we need to click on the build, and if all the checklist are okay, then it is automatically burned, right?
Yeah, it is automatically dumped into the controller. When you press this build button, after that you don't have to, you just have to wait to get this this dialog box pop-ups, and it wait for it to complete. Then when your all of them are green, then your program is successfully downloaded into control.
There is no error. That means all the program have been dumped into the controller.
Yeah.
Okay. So can I ask one more question, sir?
Yeah.
Whatever motherboard you are showing with the help of the this motherboard, is it possible to sense the voltage of the voltage and current?
Yeah, it is possible. We have already developed the PV STATCOM and that much complex circuit with this controller itself.
Okay.
PV STATCOM, single PV inverter, two stage and single stage. All the operation we have done using this motherboard.
For the measurement, we don't need to connect any kind of sensor, right?
No. You have to connect that sensing. So quantity is given to this. After the sensor, whatever the
Okay.
signals are getting, that signals are given to this controller.
Okay. Right.
Okay. So we will see the video of that.
So also we need to connect the gate driver circuit also, right?
Yeah. Get driver circuit also.
Okay.
It will be giving us the voltage in the range of 0 to 5 volt only.
Okay. Correct. So it is a kind of extension board that you are showing, right?
Yeah, extension board. Okay, so I'll play this video. Okay.
So in the previous exercise, in the experimentation, we have already seen this operation of digital in and digital output with this latch block, toggle latch debouncing block. So when we press this key PD7, here status will change from 0 to 1. When we press second time, that status will change from 1 to 0. And here we have kept two block that we already know that when rising edge is detected, it will go inside this. When falling edge is detected, it will go here. So here we kept on in this buffer we have written on when rising edge is detected. When falling edge is detected, at that time in this buffer we have saved off. So on the key press, it will print on this LCD, 1 and 0. It will print on and off. So that we will see in the experimentation. So here same program is downloaded. So this is the key PD7, this is the PD15 LED which is connected with this, and this LCD will show the status of that LED. So when I press this, LEDs become on, that is PD15. Here by mistake it is misprinted PD1, it is not PD1, it is a misprint. So here it is a PD15. So the order of this printing is reversed, so just neglect it. So it is a PD15 pin, so it is on. So we can see that here printed on LCD printed on. So if I press again, this LED is off, here printing is happen off. So similar way we can program and we can write something on the LCD according to our need. But this is just an example how we are able to program this LCD as well as key as well as LED in this for this STM32 controller using this YZoom block set. So one more thing is that here you are observing that when I press this, here off is printing from the third location. You see, this is first location is 0, 1, 2 and third. It is actually fourth block, but here it is 0, 1, 2 and 3. It is printing from third and in the first line. See, every time. So now we will go for a program that why this is happening, that we will see. So in the program here, this block we have already discussed. Then also let us repeat. So here X position is there. So this X position will show that from where it should start in the X position. So here 3 is written. So it will go from the fourth block. 3 plus 1 means fourth block of LCD. And this will show the line. So we have 16 cross 2. 2 means 2 row and 16 2 row and 16 columns. So this will show the address of the column and this will show the address of row. So 0 means first row, 1 means second row. If you change to 1, it will come in the second row and fourth position according to this. So this is all about the LCD program using this Weisung block set.
So I think that was clear to everyone.
Yes, sir.
Okay, so with that we will conclude today's session. We have seen the hope you understood the all of the exercise done today, and we will see more of this kind of exercise tomorrow itself. So tomorrow we will be seeing the timer and ADC and DAC. Okay. So with that I will conclude today's session. Thank you for listening me. I hope you have a good day.
Okay. So, thank you very
Can you
much.
share your contact details?
Yes, sir. Yes. No
You
problem.
can give your email and phone number if possible. And feedback forms are shared with chat. Please do your attendance and feedback. It is compulsory to all. Second thing, if you have any query regarding this session, so you may ask. We're having the same 2 sessions on tomorrow and next tomorrow from NITech, National INFOTECH Surat. We will see another part on tomorrow, that is interfacing with LCD, keyboard, ACD, ADC with STM32 microcontroller and many more. Okay. So do I have any query? Please ask. I hope. Shall we conclude, sir? Junaid?
Yes, sir. Yes, sir.
Yes.
If participants not having any queries, we
Okay.
can conclude.
Okay. So, behalf of SSBT Engineering College, I would like to thanks all participants and special thanks to National Infotech and Mr. Junaid. You have explained all practical blocks very nicely, and this session was is really will be benefited to all researcher and faculty members. And you have shown the importance of Weisung software. So it was a new for all, I think. I think this session will be benefited to all. Okay. And my special thanks to National Infotech and Mr. Viral. They have given us a permission to organize this. So thank you very much once again. So
Yes.
tomorrow's speaker.